Hello, Noir Vortex here, and welcome to another episode of my Funny Philosophies. This is my video series where I discuss a variety of ideas and kind of give my own perspective on them, and a general overview of what they are from my perspective. So, today I'm going to be talking about one that I should be pretty knowledgeable about because it's what my degree subject was in, which is computing. So I'll be talking about the history of computing a bit, core fundamental concepts in computing, and just generally the idea of what computing is and how it has affected our world. And it is pretty much one of the main, it's rapidly changed our world in the last 20 or 30 years, and even prior to that. So this should be an interesting video. So I'll be exploring historical figures, fundamentals, and also core concepts, I suppose, in computing, both modern and the older forms of computing and processing of machines. The idea of thinking machines and processing machines. Okay, so without further ado, let's crack on with it. So, obviously, I think when people think about computing now, they think desktop PCs, tablet PCs, mobile phones, even. I think a lot of the time as well, people don't often forget that mobiles are computers, which I don't know if everyone does that, but I kind of get fascinated by that when people forget that essentially a mobile phone is a computer in a smaller device. The way that we've had access to computing is changed rapidly over the years, and it's become much more of a kind of like united technology across the entire world that links everything together, especially the development of the internet. But without further ado, let's look at some of the early shit of computing. So now this is an interesting story. It's kind of getting a bit more known in the open. I'm actually reading a book at the minute by Sadie Plant about the women in computing, which covers this a lot. It just goes into a lot of detail. Because guess what, guys? The first computer programmer didn't have a penis. Mind blown, right? Okay, Ada Lovelace and Charles Babbage. Let's start at the beginning. So, Charles Babbage worked alongside Ada Lovelace, who was, interestingly enough, the daughter of Lord Byron, the old romantic poet who got around a bit and was a bit of a bad boy, essentially. But Ada was quite different to her father in a lot of ways, whereas I guess Byron was very much in the romantic spirit of a lot of poets, and was definitely a bad boy in a lot of ways, kind of wild, righteous kind of figure in poetry and the British poetry. But Ada was very different. She pursued more of a rationalist kind of. She's a mathematician essentially, and a genius woman as well, like very much of her time, but also way ahead of her time in a lot of ways, pioneering. Babbage, so the Babbage machine and analytical engine is Charles Babbage. So this is basically, he wanted to make this is all in kind of the Industrial Revolution time. So he wanted to develop a calculating machine essentially, so a machine that would be able to do quite large sums with the Babbage engine, Babbage analytical engine. And Ada worked alongside and had a very long relationship with Charles Babbage in terms of an intellectual discourse and a relationship between them both. And she helped to develop the mathematical systems for how to process several different calculations at once, as opposed to, so like for example, if you're going to do a mathematical operation, generally as a human being, you can only generally focus on one thing at a time, or one calculation at a time. The idea of that Ada developed with the mathematics that she developed for Babbage analytical engine was to do with, I think, because I'm still reading a bit about this at the minute, but it was basically to process in parallel, and which I think is correct, I think I'm not butchering it too much by talking about this. I'm not an in-depth kind of like, I've not read like in the in-depth mathematics of Ada Lovelace, but I think that was basically her major contribution to Babbage's engine, and it's really fascinating history as well, worth reading up on, as I'm doing currently now. So there's that, and then that was kind of almost, they were a lot of time ahead of their time, because the history of computing then doesn't really take off in the modern world, and this is like, what, 100 years ago, probably more, that was developed. But the history of computing really takes off in Turing. This is the next big step. Alan Turing, absolute hero of computing. So Alan Turing was a mathematician, British mathematician, who actually was very involved in Manchester, and funnily enough, where I'm from, in Cheshire originally. So he was from around that area, where I live, and he was a very skilled mathematician, and he was involved in the Second World War in the Enigma project, which was, the Enigma project was, the Germans were, it's basically about interpreting German coded messages, and Alan Turing was involved in cryptology, which is the science of decoding and the science of, I guess, the science of analytical language in terms of mathematics, essentially. And what Turing helped develop was the Enigma machine. The Enigma machine helped us decode German messages so that we could find out where they were planning to strike. It's basically, they used a way of decrypting messages for like, you know, seek things that are going on in attacks and such. And Turing helped develop this Enigma machine. It's covered a lot in an imitation game of Benedict Cumberbatch, which is worth checking out. I've not seen it actually, and that tells the whole story more or less. There's also a version of Derek Jacobi, which is very good, worth watching. Both very different interpretations of the story. Now this story, I'm going to get into some more stuff before going to the sad ending of Turing, which is really horrible, tragic, and actually a stain on British history, completely 100% stain. But before I get into that, and you're probably already aware of it anyway, but before I get into that, where was I? So Turing came up with this idea. He basically helped form our idea of what computing is in the modern world, in terms of having machines that can help with processes and help like innovate processes, but also processes. Let's just jump around a bit. Processing is a major part of computing. So processing just means processing information. So that's what computers generally do a lot of the time, is they respond to user input, but they also process information and calculate using the old CPU, central processing unit. But Turing came up with this test, which is another thing he's famous for, which is a very key component in artificial intelligence, which is the idea of, if you have a person in one room and a machine in another room, and a person, they're both separated by a wall, the person types or communicates somehow with the machine, and the human being can't tell the difference between the machine and a human being, then that kind of demonstrates some level of an artificial intelligence, which is an emerging science, and it's one I'm hoping to get into myself soon. So this is kind of very personal, interesting story. But anyway, I digress. So Turing helped develop a lot of the modern ideas around what computing could be. But he was unfortunate enough to live in the time when he was gay. So he was a gay man living in Britain, in 1950s Britain, post-war Britain, after the Enigma machine, and well, obviously his entire life he was gay. It's not even worth discussing really further, to be honest, because, you know, he was gay. And the British government, the police, basically punished him for being gay when he was, I think his house got robbed or something. He mentioned that he had like a male lover around his house, and he had to take female hormones, and he ended up killing himself. And as I said, it's a stain on British history. It's a massive stain. Only just got made right but not really. He got like an official pardon basically. I think it was 5 years ago under Gordon Brown, but Labour Prime Minister. But yeah, still one of the greatest stains on our entire British history. But that's that. Quite tragic tale. And he was a genius mathematician, like cryptologist, all the rest of it, and that's how we treated him. And thank God we moved on from that now, mostly in most parts of the world, and culture and stuff. But anyway, let's fast forward a bit. So you had computers when they originally, and where I am in Manchester has actually got a lot of precedence in terms of the history of computing. We had the first, I think, kind of like transistor cathode ray, transistor computer made was in Manchester. It took up a few rooms. I think it was at the University of Manchester. So we've got a proud history of computing in this city, and something to be very proud of. So there's that, which is something to be much more proud of than how we treat poor Alan. But anyway, let's go on. So yeah, you had the development of the transistor, which allowed for more faster processing. You still, I think at that point, had to have a lot of early programs were punch hold. Now let's talk about what a program is as well. I'm going to try and cover a bit more conceptual stuff now, I guess. So the programs are essentially just a series of instructions given to a computer to how to behave. Essentially, that's what a program is. It is a series of instructions written to convert a process into machine language. So an example of a program could be it's one of those well-known ones. Facebook's a program. It's a web application, so it's a program that's designed for the web, a social network for the web. Snapchat's a program for a mobile phone. It's an Android or iOS application. Programs can run on many different platforms, and there's many different programming languages for them, dependent on the program that you want to run. So a web application might be programmed in JavaScript, which is a web programming language, or PHP, which is another web programming language. There's lots of different web programming languages, and essentially what they do anyway is just basically convert processes that run in a software application or on something on a computer, and converts it to machine level code, so that the computer can interpret what that program wants it to do, I guess, essentially. I might have butchered that a bit. That's my first time in my phrase on this series now. I might have butchered that a bit, but I think you understand what I mean. So yeah, I've gone from Turing. Computing kind of stayed very much a governmental thing for a long time, until the advent of the ye olde personal computing, which is pretty much just the last, not the last revolution, but the revolution before the one we're in now, I think. So personal computing was spearheaded very much by, guess who? Bill Gates, Steve Jobs, Steve Wozniak as well, who is often not given his due. And then Linux as well too. Let's not shy away from that, because Linux is a great and proud history too, open source movement. Anyway, so you had in the history of personal computing, Bill Gates and Steve Jobs obviously had their kind of like competition, where they thought that, well, we've got all this technology, we've got computing, but then shouldn't we bring this into the office, into the home, and try and innovate something out of that? Because a lot, computers before were very much academic. Academics might have them, but then the idea, the great genius really of Bill Gates and Steve Jobs was to bring that into the home and the office. So bring computers and computing as a concept into the home, so that it was less of a just purely academic and maybe governmental thing, and something that would actually help with people in the home. Basically, it's quite interesting because philosophically, to this is up in the past, but obviously Apple and Microsoft are quite different now. But Microsoft took it down much more of a business route. Essentially, they wanted to produce programs that would help, like word processing packages, etc., etc. Whereas Apple did that, but then tried to take it down a bit more of a creative route, I guess, essentially. So that Paint package, I think, was quite one of the big things in the early Mac. You had this kind of paint package. Wow, you could do little marks and pixel and stuff. So there's that kind of division in those two major computing innovators, I suppose. And yeah, Microsoft are still pretty much one of the major distributors of Office software, and probably still the most used operating system is Microsoft. There's so much to explain here, I don't know if I'm going to make it in 20 minutes. So an operating system, what's an operating system? Operating system is it's just it's a way for the user to interact with the machine, and also be able to access programs in a kind of easy to use manner. One of the first operating systems was DOS by Windows. There's also Unix as well, but I just touched on DOS because that's it at my time. So DOS was the command line user interface, which I'm sure a few of the older ones on here will have used, older people on YouTube will have used. I used it. It was the first operating system I ever used was DOS, and that was you'd have to run like commands like you'd have to like CD or change drive, whatever. Like, well, not change drive actually at this point. So you had sorry, we're getting fucked out. But you'd have commands that you'd enter the computer to run or install certain programs. I think most of my exposure to DOS was through my mate. I used to play games like PC games. We even had an Amiga back in the day. So you also, along with the development of personal computing, you also had games as well. So you had the Amiga, Commodore 64, which Commodore 64 and all those kind of Spectrum and everything else, these early gaming consoles which have got like a retro kind of aura around them now. But these are these things where you could, you're running on tape, and often you'd have to program your own games, and the whole culture of video game design came out of that cottage industry essentially, of just kids in their rooms just going typing and making their own little games. Some really creative stuff like Manic Miner, for example, came out of that, and that's a really interesting history to look into. Okay, so yeah, past that age, and I've there's so much to go into it that I haven't got enough time. We've got where we're at now, which is essentially the age of mobile cloud computing, which is where we are now. So obviously in the personal computing age, we had a lot of desktops. Desktops were the first thing, which is having a desktop computer that you could store in your home. Then after that came the development of mobile laptops. So that was a big thing. It wasn't even that long ago really, and then Apple bought out the iPhone, which was a big development and a big shift, a massive shift. And as much as I have a lot of misgivings with some of Apple, sometimes I've got to state my claim I'm a PC guy, but Apple and the iPhone was just, and the iPad, the iPhone, the iPod, these were big game-changing moments in recent history of computing, and that was massive. But anyway, that's that covered. Obviously, along with all this, you've got the development of the internet. There's something emerged out of ARPANET, and the internet evolved out of military and academic networks of computers. So a network in computing is just a bunch of computers that talk to each other essentially, and then what the internet is just basically a hell of a lot of computers talking to each other and sending commands and sending instructions to each other. That's basically the most basic fundamental terms. That's what the internet is. It's a hell of a lot of computers networked together through telephone networks, which I guess a lot of you are going to understand that implicitly. And that so Tim Berners-Lee was the father of the internet, modern internet essentially, and helped develop the framework for it. And so where we are now is we've got 1 minute, 25 minutes, screw it. We've got we're in the age of mobile and cloud computing. Cloud being storing things on cloud server. What's a server? People aren't going to know that, are they? A server is just, in the most basic nutshell of it, is a computer that provides other files and services for other computers essentially. So most basic example, I've got like a cloud hosting account where I host websites that I've made and helped out with. So that's we've got to still have a server rack where my host has their computers where they'll store my files, and then every time a computer makes a request on the internet to gain access to one of the websites I worked on, that server will serve that file. That's what a server is. Anything else? Obviously the internet revolutionised a lot of connectivity around the world. It's revolutionised the industry, and pretty much, I don't even know how many percent, but a hell of a lot of the industry in our world is based around computing. And if we didn't have interlinked connected networks now, our economy would probably dissolve in a week, if probably less. So computers are essentially the drivers of our economy now, I think, in a lot of ways. And so yeah, computers, and like speaking of someone who's been in computing now for 10 years, I recommend it as an area to study because it is still a developing trend, still a developing area. There's literally, if you go into computing, there's 1,001 different ways you can take it. Now, for me, I took it from doing my computer science degree, and I went and specialised in web development, but then I also did a bit of e-learning development, which is a very interesting, kind of emerging area as well in a lot of ways, in terms of it being used even more. E-learning is just electronic learning. There's a history for that as well, but again, I haven't got a lot of time to go into this. One very interesting emerging area, which is still a big question mark, going back to Turing, artificial intelligence. Now this is the area that deals with computers that can be said to have imbued with some kind of intelligence. That doesn't necessarily mean it'd be like our intelligence. This is where I think a lot of people assume about artificial intelligence that it's all crazy computer science guys wanting to create human-like intelligence in machines, but really most of it's not about that at all. There's probably a few people who are trying to develop robotics which can mimic human intelligence, but most of it isn't about creating a copy of human intelligence. It's all more about speeding up processes. It's manufacturing, it's already used, but then it could also be used for machine learning and neural networks, which essentially are ways that programs, as I described earlier on, can learn from input that they get from a system, I suppose, essentially. The last few things to cover, and then I'll end this because this is 22 minutes already, and this is probably, for a lot of people, I guess it's like having a conversation with that crazy nerd in the in the pub, which is me. So you have you've got web development again as well, which is an area I've worked in a bit, and that continues to innovate and get more interesting. There's way too much to cover in that for this video, but I think I've probably covered enough there. So with that, I'll say adieu. I've been Noir Vortex. This has been Funny Philosophies episode 9, I think now, and I hope you've got a half decent understanding, if you didn't have already, of the history of computing in 20 minutes. So yeah, system out, print line, goodbye.